You're welcome once more to our class, and I am going to take you today on chemistry. Our topic today will be on gas laws, and before I start, I would like to briefly go back to our last class, which is on IUPAC nomenclature. I remember, like I told you, there are 4 steps to achieve conventional IUPAC nomenclature. The first step there is to know your compounds, know your elements rather, know your elements, your hydrogen up to mostly the first 20 elements, because they are the ones that comes and goes in our chemistry. Know the first 20 elements, know their signs, know their signs. Once you are done with their signs, know their charges, the one that has +1, +2, +3 in the electronic configuration, like I told you, their valency, know them. Once you are done with this, second thing to know is that the second compound in every combination must have an IDE attached to the end of the word. Example, fluorine. Now we remove that INE and we add fluoride. When we have sodium and fluorine joined together, it's called sodium fluoride. Hydrogen and oxygen is called hydroxide. See, so it's just there. You have to remove the ending word and add IDE. That's the first step. The second step is to check if it is a molecular or an atomic. It's an ionic rather if it is a metal to a non-metal. If it's a metal to a non-metal, it's ionic. If it's molecular, if it's a non-metal to a non-metal. You know what a metal is, you know what a non-metal is. +1 to +3 valency are metals. -3 to -1 valency are non-metals. Do electronic configuration on all the 20 elements and you will know the metals and non-metals. That's that. Okay, once you are done with knowing whether it's molecular or ionic, then you know if it's going to have a Roman figure attached to it. The Roman figure attachment depends on the atomic charge it produced. Now, like I told you, if this one is having 2 atomic charge, this one having 4 atomic charge, that is 6. Tetra also surface 6. That tetra also surface 6 is H2SO4. 4 + 2, 6. Tetra also surface 6. Now, if you are right, you see that 6, you have something like this, you have to add it, indicate it. We have talked about the first step, second step, and this is the third step. The last step. Note whether you have transition elements attached to it. Check whether you have transition element attached to it. If there is no transition element attached to it, no problem. If there is transition element attached to it, check the valency of the transition element. Whether you are going to add a suffix to the first element. We use an example that day. We said we have okay, let me use this example now. Trioxocarbonate 4 HCO3. Now, in this point there is no transition element, but the valency that this one brought out plus the one that this one has, this is a radical, this is an element. This radical has 3, 1 + 3, 1 valency plus 3, which is 3. 3 + 1, which is 4. That gave us this 4. But why naming it? Due to this oxygen already has 3 attached to it, we need to pronounce the 3. That is why we have the tri and oxo, and we have carbonate. For the hydrogen is not pronounced because it is not a transition element. Hope you are following. Transition element, like I said, are from 21 up. Chromium, vanadium, titanium, iron, copper, zinc, those ones. Whenever you see them, we pronounce them. But from 20 down, it's hardly we pronounce them. Hardly we pronounce them in the compound. Hope you are following. I think that is all you need to know. That is just all you need to know. Addition to what I taught you, I've explained more than what I taught you that day. Okay, without wasting much of our time, let's go to what we have today. We have Boyle's laws, and we are going to talk about Boyle's law, Charles' law, general gas equation, and Adé gas equation. Let's talk about Boyle's law. This is a law of gases. There is a law that it says, and that Boyle's law states, I'm not going to write, I'm just going to dictate it for you, but the formula will be written that the pressure of a given gas, a fixed given gas, is inversely proportional to the volume, provided that temperature is constant. The pressure of a given gas is inversely proportional to the volume, provided that temperature is constant. That means P equals to K as a constant all over V. That means that constant will be equal to PV. Therefore, P1 V1 equals to P2 V2. Once it is constant, there is pressure and there is volume. Once it is constant, this gas is constant, there is pressure and there is volume. Now, as the pressure increases, the volume increases. The pressure of the gas increases, the volume of the gas increases. If you are putting a gas in a cylinder, as the pressure is increases, the volume is increasing. Okay. We are going to look let me say some certain simple questions in these gas laws, and without wasting much of our time, it may take us a little time. All right, we're just going to look some certain questions, and we are going to explain what we really mean by P1 V1 P2 V2. You're welcome once more, so that we'll check on these questions. All right, like if you look at the board, you see the question I wrote that says 200 centimeter cube of a gas has a pressure of 510 millimeter mercury. Now, calculate the volume if the pressure is increased to 780 millimeter mercury when the temperature is constant. That is always how this question always states to be. Either they'll give you the first and the second, asking you to look for the pressure or the volume. So now you look at it, you say, all right, since the formula says P1 V1 equals to P2 V2, that means if they give us P1 and V2, we can find anyone. We can find anyone. So what do? We first of all state our P1. The first pressure they gave us is 510. Second pressure 780, first volume 200. The second volume is what we are looking for. Now we bring down our formula. To look for V2, we need to make it the subject of the formula. Now we divide both sides by V2. We give us P1 V1 all over P1 divided by V2. P1 V1 P2 equals to P2. Okay, so by so doing, let us substitute everything we have here into this place. P1 is 510, V1 is 200, divided by P2, which is 780. If you press your calculator there, you will see 130.7. 130.7, some other numbers. Now we approximate it to get 131 centimeter cube. Remember, what you are looking for is volume. So after approximating to the nearest whole number, and will give us 131 centimeter cube. That is it for Charles' law. For Boyle's law, there is no way it's talking about pressure and volume. No other. What they will ask you is just P2 and V2. So it's left for you to alternate. If it's P2, they ask you, you use P2. If it's V2, they ask you, you do it this way. That's just it. There is no two ways about it. The next question, the next top point we are going to go is Charles' law, where we talk about temperature and the volume. All right, let's go to Charles' law.